Here I'm going to continue talking about the try except blocks. Now, I've talked about try except blocks in the context of opening up files and dealing with file input and file output, but here I want to talk more about them in detail. So let's get started. Here I have a print statement just to show that start here is going to be printed whenever we run this. I'm going to assign the integer 10 to this variable x. And then I have this try block. But before we start talking about try blocks, let me comment this out. And let's do a quick review. The quick review is going to say, or highlight, what the issue could be. So the issue is going to be, if I run this, and of course it's going to say start here, and it's going to say please enter a number, and I'm going to cast that number to an integer. So let's say I say ten, and I hit enter. Well, ten, remember, everything I enter for input, it's a string, and we need to, in this case, I want to deal with that string and cast it over to an integer so that I can do some math on it. For example, in this case, I'm going to divide 10 by whatever the user input is. So if I divide 10 by 10, that's what I entered. Well, Python doesn't know what ten is. Of course, it knows what 10 is. So even if I say 10, that knows, that tells Python, hey, look, that is a string of 10, but when I cast it over to an integer, it becomes really 10, the integer. And so then I can say 10 divided by 10 equals 1, and it ends here because I'm printing ends here at the bottom, right? So that's the idea. It's one of two things. One is every time you ask for input, you're getting a string type. And then that's why we need to do this manipulation here and cast it over to an integer. We assign it to user input, and then we manipulate that user input, which we know is a string. It's an integer at this point, and we can go on. So again, the idea is we don't want something like this, like gibberish, to try to be casted over to an integer, because that can't be casted over to an integer. So notice how we stop the execution when this happens. This blows up on us. We get this red error message. This never gets printed. Ends here never gets printed, right? So it doesn't gracefully continue to run our program. It halts the execution, and that's bad. That's bad. We want to recover from this if we possibly can and continue running our program. So what can we do? Well, you guessed it. We can have this try block, and this try block comes to the rescue. Why? Because we'll be able to execute this, and let's go through this. So what's the try block? The try block is going to say, hey, Python, I want you to try the following code, right? What's the following code? Well, I want you to, whatever's inside of this try block, I want you to try and execute that. If you have an issue, if there is an issue, go ahead and go through the except blocks and recover from them, and we'll go into that in a second. But if you don't have an issue trying, basically executing whatever is in the body of the try block, sure, go ahead and continue after the except blocks, which is going to be prints here. So let me show you. If I run this and I say 10, for example, notice that this is going to it's going to print out some messages, but this will always execute. This will always execute. It's from the finally clause, will always happen, and ends here does get printed. And that's what I want to highlight, at least for now. It's at the ends here does get shown, it gets printed. And so it doesn't halt the execution of the program, even though there's an error. It continues going through it. Now, maybe in the real world, we keep prompting the user for, hey, you haven't entered a 4-digit integer, for example. Can you please enter? And we'll keep asking you, until you enter it properly. This case, just for demo purposes, I didn't do that. I didn't do a while loop or anything. I just said, hey, look, just print it out. This is an issue, and go on. So let's get into these details. What's happening here? When I enter in, I ask for the user input. I enter it in ten. We try to cast ten to an integer. This line has an issue. It's going to go through the except blocks and say, hey, is this an IO error? No, it's not. Is this a value error? Yes, it is. Well, then go ahead and print can't cast this value to an integer. And that's what happened when I ran it. Let me just highlight that. That's what happened when I ran it. It says cannot cast this value to an integer. That's what happens here. Now, if you had other issues, if it wasn't a value error and you did have an exception, being thrown, it would continue going through, and we'll do this one now. 0 division by error. So if you say 0, well, you cannot divide by 0. You cannot divide by 0 will be printed. Why? Because we take in 10 here. Well, 10, and we divide. X is 10, and we divide by 0. We can't do that in math. We can't divide by 0. This is going to throw an exception. Which one? Well, we're catching it here, and we're basically doing something. Whatever that is, I'm just printing it to the screen for now, but then the finally will always execute. That's another important thing I wanted to mention in this video for completeness. Finally, the finally clause will always run, whether the try is successful or it is not successful. So you can see that here it's not successful, but it still prints that. And most importantly, it doesn't halt the execution of the program because we have a try, except block, and it ends here, gets printed. Now, the other thing I wanted to mention is that you don't want to be, you do want to be granular with whatever you're trying. So in other words, you don't want to enter everything here, make this like 50 lines or so. Why? Because this is not, sensitive. It's not vulnerable to something going wrong. And the assigning of this variable here, x equals 10, is not, that can't go wrong. There's no vulnerability here, like that. There's nothing that could go wrong here. So why, put all these things in here when you know that that's never going to have an issue. And plus, your stack trace will have an issue. Well, not have an issue, but it'll be unclear. The stack trace will be what tells you, hey, this, this went wrong here at this stack, at this line, at this, and it'll give you some information. And so if you put too much info here or too many lines, it's going to be a little bit more crowded. Not that you can't get to it, but it just doesn't, it's not helpful. So the rule of thumb, the best practice is have your try blocks to be very granular. Only the things that could go wrong, we'll try those. One more thing, and again for completeness, is that notice how we're trying something, some block, and if that goes wrong, we go line by line here in the order of the exceptions. And it's going to say, hey, is this an IO error? If so, do this. If not, check is this a value error? If so, do this. Otherwise, do this. And so on and so forth. What we don't want to do, and by the way, the exception here at the end, this is the most general. This is the broadest one. That means that it goes from very specific to more broad. So as you work down, you're getting broader and broader. So this would still work. It's just not going to be as helpful, but this would still work. If you say something like TEN, it would still work. It just says this is a general error, so you're not getting specifically what the error is, but whatever. You can do this. It's just not best practice. It's not recommended. It's recommended to be more specific. So the other thing to note is that you don't want to put the more general one here. Why? Because that means that this will always get picked up, right? And these will never happen. So if I do something like this and it's TEN, this is a general error will happen because this will always be picked up. So it's not going to be helpful. So in other words, this code will never be reached. So you don't want to do that, right? In other languages, you're not allowed to do this. Like it won't let you even compile. Like for example, if you're using Java, but in Python, it continues to let you do this. It's just, you should be aware that this is not good practice and you do have unreachable code. I hope this is helpful.